Hello everyone. Welcome to the Cohort 4 of Women in Ethereum Protocol. And this is week 2. And my name is Adma Chaudhary, and I'm the lead facilitator for this cohort. So, if this is the first time that you are joining this call, then you can go through this repository to know more about our program. So, this is the Discord link where we have shared the resources, the learning resources for this week. So, if you have not checked it out, make sure to check it out. And yeah, so today we have Mario with us. Mario is from the Ethereum Foundation. And today we will have the session in the format of Q&A, and it will be based on Ethereum protocol fundamentals. So we asked the participants to share their questions as an assignment in a Google Sheet, and whatever questions they have
Yes, of course.
yeah, so we shared the resources with our participants and they have submitted the questions. So the first question is on quantum threat, and the question is that I keep hearing people talk about quantum computers, maybe breaking today's cryptography one day. How does Ethereum even begin to think about switching to quantum resistant methods without breaking anything? And is that even realistic or just a future talk for now?
Okay, thank you. So I think before we jump to the questions, I also wanted to just thank you for inviting me. Thank you so much for having me today. And I wanted to say I'm excited that there are so many people, so many women eager to learn about Ethereum and the Ethereum protocol. So yeah, thank you so much for having me. And also thank you so much for watching the introductory materials. I just wanted to say a couple of things about that because I shared my talk, which was the introduction to the protocol from like 1.5 years ago, maybe. So it's still relatively up to date, but some parts might be a bit outdated, especially the part on the roadmap and the future and the research, which some of the questions I see are touching. So I'm sorry about it. I thought that it will be better format to just give you all the resources to prepare, and then we will follow up with discussion about what you've seen. So I hope that you had a chance to see my presentation from the study group. And there's also a bunch of other resources you can study, and always reach out to me if you have questions. So to dive into these, also I was hoping to do this live. So if you have any follow-up questions, we have a bunch of people on the call here, so feel free to also just like use your mic and elaborate if you are not sure about something. And I will do my best to answer all of your questions. I might have to point you to some places to study more. But yeah, let's start with the quantum stuff. It's a big topic. It's a big it's a
Mario,
big question.
just before starting, can you please introduce yourself to the
Oh
people
yeah,
about the work you
yeah.
do at Ethereum? I think they will be more than happy to know about it.
Yeah, right. Yeah, I should have started with that, I guess. Yeah, so thank you so much again for having me. I'm Mario. I work at Ethereum Foundation for like 5.5 years now, working in the protocol support team since it was created, and the protocol support is helping with the core development. So I'm not doing directly the core development, but I'm helping with various tasks around it, helping with the coordination, helping with documentation. And what I'm doing mainly these days is running the Protocol Fellowship, which is a program that helps people to start doing the core development themselves. Ethereum is a huge project, big protocol with many clients, many implementations. As you've seen in my introductory talk, there is like dozen different client implementations basically, and specs and testing. So there are like hundreds of people working on this, and we need more people. We need more talent. We need young talented people to work on this. It's very complex. So even the best developers struggle to somehow dive into the protocol and be able to understand. So our program helps people to overcome this and work directly with the client teams. A part of that is also the study group that I've also pointed you to. The protocol study group that we created, and the wiki that comes with it is full of resources to generally learn and study. And the EPF provides more like the direct impact, the practical way to work on the protocol. So that's what I mainly do. I come from like a hacker background, from crypto anarchy background, running hacker spaces, running community spaces. So I'm very dedicated to the community. I love interacting with people and just like bringing more people in. So always open to everyone to chat, to help out if you're curious about these things. Yeah. And again, like I would like to also hear something from you guys. So feel free to, if you have any questions apart from what we discuss here, if you want to follow up with some comments, I would like to hear some direct feedback. Feel free to speak up, I guess.
Yep, I think you can share your questions on Discord or in the chat, whatever you're comfortable with. I'm following up with the Discord. And you can also share your questions on chat here. So yeah, yeah.
Yeah, thank you. Yeah, so should we jump to this question or anything else we want to do for the intro?
No, I think we can start with the question.
Yeah. Yeah, cool. So yeah, the quantum thread. It's a big topic. We start with not just like a broad topic, but also a pretty advanced topic. I usually start the protocol intro from the intro, and this is a bit more advanced topic for the future. But it's a real thing. So the thing is. There are certain things called quantum algorithms. There are certain things that a traditional transistor 0 1 bit based computer isn't really capable doing efficiently. But already years ago, dozens of years ago, there were algorithms proposed for certain problems to make them faster using a different computational model, quantum computing. And technologically, we are slowly approaching this paradigm, although still not there. So first thing to realize is that cryptography relies on math, on the literally the rules of the universe, on physics, right? And unless we break the physics, we cannot break the cryptography. But the way that we enforce these rules, or the way that these cryptographic protocols operate, for some of them, I think in some questions there were some even mentioned like ECDSA. Some of them rely on problems that are possible to parallelize or to vectorize in a way that the quantum computer could solve them magnitude faster, right? So there is this idea that certain parts of the cryptographical stack of Ethereum could become vulnerable to some quantum attacks. But so what does it mean in practice? Like again, like this is not just Ethereum. This is everything. This is all the public cryptography we have. This is all the encrypted communication, the HTTPS, TLS, the banks, the other cryptocurrencies. So it's not just our problem, and there's a lot of research on this. There's a lot of alternatives for what we are doing, and even some alternatives that are coming from more traditional approaches. So, like for example, there was a big discussion. So the Ethereum stack, as you can see, it continuously upgrades. Right? We have a big change every year at least. Now the latest one was Spectre. Now we are working on Fusaka, and we significantly change big part of the stack all the time. So the general idea would be that in some of these future upgrades, when either because we want to be like future proofing, or because it really becomes a threat, we would have to do it faster and coordinate faster, but it's not going to still happen overnight. It's going to take a couple of years, so we'll have enough time to coordinate and replace some of the cryptography that Ethereum is using with something that would be safe. And because Ethereum really coordinates to ship an upgrade like maybe more than once a year at this point, we would have definitely enough space to be able to coordinate on this and upgrade Ethereum with some existing proposals. But also now Ethereum is going through a bunch of these upgrades. As I mentioned, there is maybe you heard about the lean consensus, and these are like future protocols that Ethereum will be switching to, already being designed with some quantum resistance in mind. Or I mean, I hope so, because it's also a big discussion. Like there are many trade-offs. A great example is the KZG. So the blobs on Ethereum are using KZG commitments. The PeerDAS is using KZG commitments, right? Is a commitment to a polynomial, and it's this like crazy double elliptic curve cryptography, which is not resistant to quantum cryptography, quantum resistant to quantum computing. So when we are deciding on the KZG, there was like bunch of trade-offs, bunch of other like IPAs or some other sort of commitment schemes that we could use in order to achieve similar outcome. But the one of the only downsides of the KZG was the quantum non-resistance, and we went with it, right? Because it was the best option at the time. So that's, for example, a big piece of cryptography that's going to be have to change, and the ECDSA as well. I'm not sure if Schnorr signatures are quantum resistant. Yeah. So again, like with the roadmap, with the progress of Ethereum, like we coordinate on this, and we future-proof the Ethereum as we go on. Yeah. Hope that answers the question.
Yeah, I think it answers. So let's
Started a
move on
bit
to the next.
broadly. Yeah.
Sorry.
Yeah, I was maybe I started a bit broadly there, but yeah, go ahead, please.
Oh, yeah.
Yeah, if you have any additional questions, concerns, feel free to type in the chat or ask me. If
Yep.
one small bug happens in how a client handles data, could it really mess up the whole blockchain? Like everyone ends up in different block hashes. Has anything like that ever happened? If someone actually found a collision in Keccak 256, what parts of Ethereum would totally break first, and what would developers do right away? Is there a backup plan for that? Okay, there's a couple of questions. First of all, what happens if one small bug happens in how clients handles data? So how client handles data is also a broad term. It can mean many things. The question is whether this data handling pipeline, this part of the client, is the one which is resulting in the different root hashes and different consensus fork choice rule, right? Like whether in case that this is why we have the client diversity. So the idea is that we have like 5 clients, and each have, let's say, 30%, 20% of the network. And if only one of them has a bug, right, then only this part of the network is down, and the rest is more than 66% is still up and is able to reach finality. So if there is one which is less than which each of the client has less than third of the network, we are always safe and we reach finality. Now, uh, it's possible that this happens. It happened maybe on mainnet, like I recall like 4 years ago. There was this thing with Get doing some fix like this, and I think Optimism team wanted to test it, so they sent a transaction which triggered the bug, and then some of the clients, I mean, Nethermind like forked off basically, and people who were using these clients ended up on a different chain basically, and had to update the version of client that fixed this. So the way that we have the client diversity and the approach to the protocol is that not a small bug cannot surprise us and take down the whole network. The most critical example of this was recent Holeshky incident in the testnet when we were testing Pectra back in February, March, end of February. Then the testnet had a critical bug, which was in a way that the different clients process the config. It was just a stupid configuration bug. It wasn't even like a critical consensus thing. But because of the how the deposit contract was configured, most of the clients interpreted the data in a wrong way, and they forked to many different chains, and it took like weeks to recover the network. It still has a huge exit QE because of all the slashings. So a look into the Holeshky incident. There's a good post-mortem that I wrote in the PM repo on this. That's like the worst incident, but it was on testnet there on purpose because we were testing. So there are ways that the systematic approach with the client diversity, but also the protocol approach with the fork choice, which always follows the heaviest tree, heals the network and is able to recover it. If someone found a collision in Keccak, so again, like when you find a collision in a hash, like Keccak is the SH. It's a very modern hash, so it would be pretty surprising that someone actually finds a collision right away. That would be, of course, very bad, but it really depends on what kind. Because when you're talking about like SHA1, SHA1 or MD5 collisions, like these like old hash schemes are still being used in production today, although there were collisions found, because the collision means that you found like very specific circumstance where the different inputs result in a collision. It's a very small chance that it happens. Like it's hard to reproduce it in a practical attack. So I think that we would have enough time to react and again upgrade Ethereum to somehow handle this, but it will be hard because the Keccak is very fundamental to how Ethereum works. To the whole current state is hashed by Keccak. Hopefully, like this sort of attack wouldn't break the state and the root hashes, and we would be able to somehow this is similar to like weak or this is what where the weak I would say that where the weak subjectivity helps, because with the history expiry, like we have this rolling blockchain, right? Like we have some finalized history, and I would say that if we want to change the hash scheme, we could consider some point in the history as the common point that we know that wasn't attacked, and we built on the new hashes from there. One example would be the Merkle trees, the vector commitment Merkle tree structure that was proposed as an alternative to the current model. There is also the binary. I should have mentioned it before actually, because this is vulnerable to the quantum resistance to the quantum computers, the vector commitments, but the binary trees that are proposed by Ignacio is the latest idea on how the state tree could look like. So if you look at a lot of the binary trees, that's the latest proposal on the quantum resistant trees. Yeah, I hope that answers the question. I hope it was all right. Now that I listened to myself, I think that this is a bit advanced again for the protocol intro, but I'm very happy that you're curious about this advanced research stuff. But it's pretty cool. I hope I'm not too advanced. Like if you don't understand anything, if you want me to elaborate, please feel free to ask.
Yep. Thanks, Mario. I think anyone who has doubt can share your questions on Discord or in the chat, and we will go through them. This is the next question.
Yeah. Yeah, I'm sorry, I'm way too advanced. So if there is something you want me to elaborate on, please ask. I realize it now that I listen to myself that I'm in this mode where I just, um I talk to the more experienced developer, say I understand that you're just starting, so I'll because I try to like really give you the real image of how it looks like and give you the option to dive into the different things and study it based on the stuff that I mentioned. With the or there's a hand up, yeah? But you wants to ask something?
Hello. So I'm asking a
Hello.
question. When I read through the documentation of WiEP Cohort 4, I saw that we were using Python. I'm just curious. I have a background of Web 2, some Python, yes, but then I thought you're going to use like Solidity or Rust since it's blockchain. Please help me understand that.
So asking about
We could,
languages in Ethereum, right? So that's a good question. I understand it might be yeah. Well, can I speak? Yeah.
yeah, sure. Like I didn't
Yeah, the
get the
question.
question actually.
Yeah. The question was that like Omega here, is experienced from the Web2 in different languages and that you use in your examples or in your curriculum you use Python, and whether it's the language for Ethereum, whether Solidity or Rust, that's what she asked about. So let me address this because I understand it can be a bit confusing, but I would say that so with this client diversity approach, with the how big the Ethereum ecosystem is, we support almost every language. There is some libraries, clients, tooling, specs, testing done in some language. So there is again, so from my presentation, if you've seen it, we start with the specification, right? Then we do implementations based on that, and we test them. We have a bunch of tooling. The specification itself, the very first part, is in Python. The specs are originally written in this like mathematical white yellow paper. They're written in Python, not because like it's more readable to programmers. It's great to have Python instead of crazy math symbols, but also you can use it to actually generate tests. They are executable specs. So it's sort of a client implemented in Python, if you think about it, and you can compare it to the outcomes of the implementation clients. So the Python is the sort of source of truth in Ethereum and the testing tool. And then there are the client implementations, which are using all these different languages. And these are all low-level languages, okay? We need performance, we need low-level access, we need to be able to optimize. So that's Go, Rust, Java, C Sharp, NIM. There's also TypeScript. Yeah, Rust, I said, right? And there is some attempts at a C++ clients, which was just crazy, but I love it. So all of these like different languages that are happening on clients themselves. I think like the Go and Rust are like the most versatile. But then again, if you are looking into some niche stuff like NIM, or maybe if you have some Web2 background, Java, it's a big Web2 or like old sort of corporate language. And there are two clients in Java, a lot of things to work on there, in huge code bases. Sorry about my language. So yeah, basically any language invites you to work on Ethereum. I wanted to finish the thought with something because you asked something else as well. Oh, the Solidity. And then the Solidity is another part of the stack. The Solidity is on the smart contract level. It's the application layer, right? So we are talking about the protocol itself, about what actually Ethereum runs. And Solidity, Viper, Phi, I don't know, other smart contract languages, Cairo, whatever, they are just like their own language, which with their own compiler that compile this to EVM bytecode. And the EVM bytecode interpreter is what is part of the client. So then you have the implementation of the EVM itself in all these different languages, and it can interpret instructions made by Solidity compiler, Viper compiler, etc. I hope that makes sense. Yeah, I hope that answers the question. We can jump to the wallet question.
Yes, thank you so much.
Yeah. Sure. So with wallets like Argent Safe, it feels like ownership is no longer just about one private key. Is this kind of like making your wallet programmable, but doesn't it also open new ways for hackers to get in? Example, could a hacker exploit a bug in a smart contract itself? Is a great question. And yes, so I'm a conservative person. I like to keep my private key and my Shamir secret shared seed very safely, and I don't like somebody to program my wallet. It's true on one hand, but it's sort of a trade-off where the security is manageable, and this applies actually in all of the Ethereum. So yes, we have these smart contract wallets. We had them before. Now we even have account abstraction where we can make it more native, more easier to use these sort of wallets. So Safe is a good example, or DS Proxy, and these smart contracts wallets that enable you to build more complex transactions, or just like give you more options how to recover the money. It's a great for the users. It's a good user experience that we want. But we also introduce more complexity. We introduce more attack vectors, more attack surface. And the idea is that we'll have to learn to manage this. Same like when we are building Ethereum protocol, we constantly add new features to make it more complex. We need to learn how to manage the complexity. So we have some, I explained actually, I believe in the introductory talk, there is a sandwich complexity model, there is encapsulated complexity model. And with the wallets specifically, like, these wallets have to go through audits. These wallets have to go through some maybe formal verification process. So there are ways to make them more secure, to give us more confidence to use them. Again, personally, I try to keep my operational security very high and minimize some threats. But at the same time, I'm using some of these wallets, maybe with smaller amounts, or those that already has some sort of Lindy effect. Lindy effect, I think coined by Taleb, means like that something existed already for a long time. That means it's also going to exist for a long time. So if we have one of these wallets that already is holding billions of dollars for many years, it's very small chance. The chance that it's getting hacked is smaller and smaller, basically, because it's been already like proven by time. So yeah, definitely like don't use some smart contract wallets that you don't trust. Assign your 7702 wallet to some malicious contracts. Like always make sure that you know what you're signing, what you're using on Ethereum. Yeah. Hope that answers the question.
I have another question, Mario.
Yes.
So in this cohort, we are not writing smart contracts. That's the first question. Then the second question is, I noticed there are several clients. There was Get, there was so many. How are we choosing what client to work with? Those are two questions. Are we writing smart contracts in this cohort or not? Also, how do you choose a client?
Yeah. So
Because
whether you
Oh,
whether you write smart contracts, it's not really a question on me because I'm not running this cohort. It's up to you guys or whoever can answer that. I think that it's more
Yeah,
focused on the
yeah,
protocol.
I
Yeah.
think, yeah, I can take up that question. So we are not focusing on smart contract in this cohort. In this cohort, our main goal is to help you get started with contributing to the core Ethereum protocol, like the specs and some client teams that we coordinated with, and we got someone who can mentor you in this code. So our goal is not to help you write smart contracts, but rather help you get started with solving some issues and making some small contributions, and like eventually become contributors in the core protocol. Like specs, we have members from the specs team, from the research team, and also from the client teams who will be taking up sessions and also help you get started with contributing. But our focus is not on much on smart contract on this cohort. I hope that answers your question.
yes. Thank you so
Yeah,
much, Audrey.
Yeah,
thank
so
you.
this is yeah, thank you. So yeah, it's protocol focus. Is everything I'm talking about here. The program that I'm running, everything that I'm organizing is focused on the protocol itself, right? Not the smart contract level or the application level. But and the other question was, yeah, how do you choose a client to contribute to? Well, it's really up to you. What is attractive to you? What problematics? Like you guys, I assume if you are looking into Ethereum, you studied some computer science, you have some sort of like informatics background, and you know your passions, you know your skills. So on one hand, the easiest thing is the language, right? Again, we have like 6 different languages here. Which one you are the most proficient, or which one you want to learn, which one you find the most comfortable to write in. So some people choose it based on their previous experience, but some people just want to learn Rust, for example. So they start looking into the Rust-based tooling and clients. But then it all depends on what part are you also interested in. Are you a networking person? Are you a database person? Are you more like a researcher maybe? So there is many things, same like in the whole domain of computer science, informatics. Ethereum touches many of these domains, right? Whether it's and then based on this, you can see what part of the protocol you want to contribute to and which client is actually open to contributions in this part. I have this website, Good First Issues list, and you can see, like, for example, what sort of issues are happening across all these different repos. So here is like a website with a list of repos and open issues there. I think that's something that you are gonna tackle later in the cohort. But just as an example, you can see what different problematics are there or what different issues are open in the currently in the repos. And again, like I assume that in this cohort it's very introductory, but if you're serious, if you are actually a high skilled developer, again, we are looking for the best people here. It's something where it's hard to succeed. We have like hundreds of applications, like 500. We get like 20 people out of that. So if you feel that like you are the top few percent of the developers, you should definitely like dive into this further. And in EPF, what we do is like we provide an opportunity for with much bigger projects where it's something good first issue, something that you could solve potentially like as a learning exercise over the weekend or a couple of hours. But the EPF projects are span of like 4 months, 5 months, and it gives you much bigger undertake. It's like master level thesis or something like this that you need to work on constantly for months and collaborate directly with the team. So it's more advanced. And so I would say again, if you're choosing where to contribute to, and there was also a question like how you get started, like you start with something learnings and something smaller, make yourself familiar with the background, and if you have the computer science background, you're able to dive deep enough to next year maybe join the EPF cohort and undertake also a bigger project, and then get integrated to the community much deeper.
Yeah,
Yeah,
I
we have
think, yep, I think you like after getting a basic introduction to the protocol through this program, you can have it in your mind to apply to the EPF and for the next cohort.
Yeah, so the EPF cohorts are running like June till November. We are opening applications probably like May, or keep an eye on it starting like April next year. We also sorry about that. We also have the study group, so we will have a lot of information on this. Just to let you know that it's a spectrum where you start from learning, from basics, from the good first issues, like small issues you can fix and see how cozy you feel in the code base, and then you can undertake some bigger projects that we suggest in the fellowship. Yeah. So it's yeah.
Yeah, I think that answers it pretty well. So
Yeah, and let's continue because I'm worried that I speak too long. Like, feel free to cut me off. Once I get started, it's hard to stop me. So let's continue with more questions. I guess I see MEV question here. Ethereum is supposed to be neutral, right? But then I see things about MEV where volatiles basically choose which transactions make them more money. Doesn't that kind of break neutrality, or is it neutrality just an ideal? If MEV is basically unavoidable because of the public mempool, what's the smartest thing to do? Fight it, organize it, or just leave it alone? And do developers think about the technical, ethical side of this too? Yeah, that's a loaded question as well. So the MEV is something that has been around for already like 5 years or 6 years. It's been a while since it became big. So as you can see, we still have it. So I don't think that MEV necessarily. So our approach is that like MEV is challenge for the network, especially when it damages somehow the user experience or neutrality. But the real threat for neutrality MEV would be if it somehow enforces censorship, or if it really like prioritizes transactions over others. And right now, with the profit seeking, like you can just pay the fee to get your transaction in. It's not that we are somehow losing neutrality, but if these MEV tools are used to censor someone, then it's a problem. So for this, there is fossil, the inclusion list proposal, which creates like a protocol level commitment from validator that it will it will include some given transactions. So then Ethereum will achieve censorship resistance. That's something that will hopefully happen like in Amsterdam or the upcoming forks. So the MEV, so with this in mind, so MEV, the question was like whether to fight it or what. It's not possible to fight it. It's not possible to avoid MEV. We really like gave up on it a long time. We learned that we need to somehow design the protocol around it with this in mind, with neutrality in mind, and the current model is called PBS, Proposer Builder Separation, where the builders are 80-90% outside of the validator set. They search for these opportunities and then validators execute them, right? So there's the current model, and in the future, the way that the protocol research thinks about it is to integrate this in a way that the protocol is aware of it and can make it more neutral, safe for everyone. Yeah, so fight it, organize it, or just leave it alone. Like we are helping to organize it right now. Basically, that's the current goal, I guess. So basically, with the that's the thing that happened because it became much more democratic, much more neutral in a way that before the merge, during the proof of work, it was just the big mining pools that had direct connections to the searchers. But now every validator, I have a Raspberry Pi right here. Like this little boy can be connected to the relay and benefit directly from the MEV, every single validator on every single small computer, right? Yeah, that's what makes it also more democratic from the validator perspective. I hope that answers.
I think that answers pretty well. This is, I think, a short question.
If no one stores the full state, then who does? Like who pays for it, and what stops that from creating some kind of new business model that might not be fair? Yeah, I'm not sure what you mean by the business model, but let me talk to you a bit about stateless, because the statelessness, it's a really cool concept, and it's sort of it has actually like two levels. Let's say there is like something that we would call full statelessness when no one actually stores the full state. But even in the vertical tree proposal, the idea is that there are still full nodes that store the regular state as we do right now, but it gives us an option to create sort of a light client that doesn't need to store the full state, just a part of it, and a proof called witness. So basically, the closest we get to the statelessness is, or actually there is a implementation called Calibri. There is like a client called Calibri, I think, that's like a stateless light client right now. It's sort of real stateless client, I would say, in the sense that it's basically a light client. So you have the regular nodes in the network, and they're creating these witnesses, they're creating proofs that every node can download, and every light client can download and function statelessly but trustlessly at the same time. Like it doesn't have to have the full state to trust it. And the full statelessness, when nobody stores the state, like it would be sort of like sharded state, right? Like it would be based more on proofs and distributed across the network. Similarly, I imagine to what PureDes does maybe today, but it's not something that like you need to pay like you would still pay for the state. We are still paying the gas transactions. It's just that we could maybe make them cheaper because the hardware requirements for the node would be lower. And so look into the vertical trees if you're interested, basically, like because right now we have the Keccak hashes state, right? I assume you know how medical proof works. It is in the pre-reading. You have the medical proof. You need to have the hashes all the way to the all the siblings hashes, and the Patricia medical tree is like huge. It's like 100 gigabytes. So getting all the hashes from like a leaf all through the nodes all the way to the root is like, megabytes of data at least. It's bigger than blocks. It's huge. But in the vertical trees, because of the vertical commitments, you can aggregate them. You need just a direct path, not all the siblings, and you can aggregate them into a single commitment. So you just have a single witness, just one proof that can verify the root instead of all these hashes along the way. So it's a quick explanation how it works under the hood. Hope it wasn't too advanced. I want to run a node. It's just really expensive. I see a question about node here, and I want to talk about this for a second because I'm a very avid node runner, and I showed my Raspberry Pi here a second ago, and it's not expensive. Or hopefully, like in Ethereum, the idea is not to have it expensive. You can use almost anything. My favorite approach is to use an old laptop. Also, I have one right here. I'm gonna pull it now, but I have a old laptop which cost maybe like $100, and I put a new SSD in it, which is another 100, and I'm running a node. That's all you need. It's really simple. And if you want to use if you're using mainnet, you're paying the mainnet fees, and you want to use it with your node, I mean, you already need to have enough, like the few $100s to build like some low performance node. But at the same time, you can just run testnets. If you just want to learn about Ethereum, you can run ephemery. So for example, universities are doing this in Asunción. I heard about this, like they are using ephemery testnet, which is the smallest footprint. You can run it on anything on a phone. It has like 5 gigabytes. It's nothing. The smallest Raspberry can run ephemery because it resets every month, so you have always tiny state. So if you just want to experiment, if you just want to learn about how these nodes work, how to connect them, how to run them, just use a testnet, ephemery for the lowest. Cool. I just wanted to comment on that because you should definitely run a node. It's great. It's fun. It's very important if you are running external SSD. I think it's possible if you like plug in SSD. So now SSD, or if you connect a drive, you have a USB, you have SATA, you have M2 slots and VME, right? Considering the speed now I'm speaking about, right? So USB will be the slowest option. And I think it's possible. I think it might be possible if you have the USB 3, the bit faster USB connection. But again, you don't want to run like a validator or something like very heavy dependent on it, because it's going to be bottleneck. It can cause issues. Like it's best to just use directly SATA or directly NVMe drive. But technically it's possible, of course, yeah. Or actually what you can do as well, like there are a bunch of optimizations you can do. Like for example, what I'm doing is that I have a slow disk and a fast disk, and the fast disk is for the current state, and the ancient data, the old history, goes to the slow disks, right? Yeah. Let's me answer this about the consensus layer. Since the consensus layer is responsible for fault tolerance and security, can you elaborate on how security works in the consensus layer, and what can someone interested in security contribute to? What should I focus on learning to be involved in security on Ethereum? Okay, so security, well, I mean, if you're coming from security background, there is a lot of like traditional approaches to like pen testing, bug bounties, right? And these sort of approaches apply on Ethereum. There are actually a couple of things. So with the bug bounty, you can check. Let me send you a link quickly. There is the bug bounty program run by the Ethereum Foundation that applies to all the mainnet infrastructure or the core protocol infrastructure. You can read about a bunch of details there. And now, generally, like there's a security team in Ethereum Foundation. You can check what Frederick is the leader. You can check what Frederick is doing. We also have some sessions with him from the EPA for the EPS, and he's leading this effort that makes sure that there's a proper testing in place, proper audits, and so on. The testing phase in the protocol, the most important part is the testing phase, where we are testing the clients before some hard fork in numerous ways, but part of it is more like open to pen testers, hackers, in a form of attack nets or these bug bounties that are boosted like right before the hard fork when the client releases are out. So yeah, you might want to do look into the consensus bugs, into fuzzing, into any sort of regular red team approach to try to attack the network on the testnet, of course. Yeah, and you can apply for the bug bounty based on that. You can see some effort specifically for like better audits, also like clearing up dependencies, right? Like some of these tools have like crazy big dependencies that the libraries can be compromised and so on.
The next question is regarding the merge.
Yeah, I'm curious about the choice of consensus. Well, I understand the shift from proof of work to proof of stake. Why was POS specifically chosen over alternative like proof of history or a two-layer consensus model? I'm interested in the technical trade-off and advantages and ideal path for Ethereum. Well, honestly, I cannot really answer this without knowing more by what you mean with the alternatives. Like, what are the alternatives to it? What is the proof of history? What is two-layer consensus model? Because it's pretty abstract. We're talking about specifics. So like the proof of stake is something that has been envisioned since the Ethereum was created. It's something that's been worked on and iterated on for many years. There was the Casper paper, right? The finality gadget, and then the ghost, the fork choice rule, two papers that got compiled into Casper, into the current sort of form of consensus in like 2018. So it's been multiple like iterations of these papers and approaches to find like good decentralized. So again, like the tenets of Ethereum that drive this that we are aiming for with the proof of stake protocol is like to be as decentralized as possible. As I said, everybody can run it on a small computer somewhere and validate the network. We can have a lot of validators. Maybe it was actually overdone. Now we have like more than 1 million validators. Maybe it's too much, but that's the point. Like the network is able to handle even more than 1 million validators at this point, even twice as much probably. So that's something that was considered. Yeah. I mean, I'm not aware of any like other viable alternatives that would somehow fit the Ethereum, because again, another thing is the scalability. Ethereum was planning on execution sharding. Now we call it dunk sharding. We have this data availability sampling. That's something that directly works with like having the validator set doing these duties. So that's set that sits in the in the design path there.
Yeah, so the next question is on client diversity.
The principle makes a lot of sense, but are there significant downsides? Could having multiple client implementations slow down protocol upgrades or introduce new complexities for developers? We know that client diversity help keep network safe, and if an issue occurs in particular client, it doesn't affect the rest of the network. But are there any downsides of this client? So what are the question is some cons, some downsides of client diversity? That's an interesting question, and of course, the decentralization is sort of a downside if you think about it. Like having all of these different clients to coordinate, to work together, it introduces certain overhead. But there is no point doing it without it. I think I would compare it to the question like, what is the downside of Ethereum being decentralized, right? We could be like some bank having one server and just running a SQL database or some Google Sheet, right? We could be Solana and doing the same. I don't know. But we are trying to do it as decentralized as possible, because despite these like decentralization downsides of more coordination, maybe slowing down the network, we have the neutrality, the censorship resistance, the empowering everyone. So the answer is like the downsides right now is like it creates more complexity when we are working on the upgrades. In some ways, it's good because more minds equals more productivity, more ideas. So it helps to have more people who understand the protocol, who work on it. I think generally like it's just making it more robust, but also introduces like more discussions, more complexity. If there is one dictator, it would be super easy. If there is just like one guy who says the way it's gonna be, it would be very easy. But sadly, it's not the case, and now we need to have much broader discussions if we want to make some significant change. But it's just necessary for the way that we work, and of course we try to make it more efficient, trying to make these processes better. Testing is a big bottleneck when we need to test. Right. The real problem is that it's squared, right? Like we have let's say we have 5 execution clients, 5 consensus clients, which means we have 25 combinations. So it's squared, right? It's power to 2. So now if we introduce one more client, it's going to be 6 times 6 is 36 combinations. And now try to run 36, which is 72 different clients on your laptop to test it, right? Some people here mentioned they have trouble running a regular node, and now I'm supposed to run 72 of them on my laptop just to test whether all of them communicate at the same time, right? So it makes it bottlenecks how we are able to test, makes it a bit harder. And I think that client diversity is great. It needs to have some some reasonable limit. I think the 4 or 5 clients on each side is perfect right now.
The next question is on cryptography side.
Yeah, given that asymmetric cryptography, it's because I was talking about asymmetric cryptography in my intro, I guess. I was like shilling this there, but of course, so the key distribution of symmetric systems. Why do modern protocols like HTTPS still rely on hybrid approaches that combine both symmetric and asymmetric encryption? Also, what are the trade-offs between security, computational efficiency, and scalability that drive this design choice? How does this principle apply blockchains? Oh, yeah, I'm not sure how you mean the second part. Just let me talk a bit about the cryptography there. So the asymmetric cryptography, as I explained, it solved one problem of the symmetric cryptography, but doesn't mean that it makes it obsolete. Symmetric cryptography is still like widely used and necessary. It's just like for certain use cases, it's not really usable or inferior. So for example, I have Lux on my device right here. I have like 3 Lux devices right next to me, which means Linux key management, encrypted drive, right? That's symmetric encryption. And in a case of the HTTPS, or even if you look at like modern encrypted communication protocols like Signal. Signal is using this double resh protocol. If you're interested in cryptographic protocols, like Signal is like beautiful, and they are using this forward secrecy protocol, which is using the symmetric to distribute the asymmetric keys, right? So what you might want to look into is how the Diffie-Hellman key exchange works. So the Diffie-Hellman key exchange is basically this. So you're basically just using different cryptographic primitives, symmetric, asymmetric encryption, hashes, proofs. There are all these cryptographic magical primitives that you can combine to create some system that works together. And yeah, it doesn't mean that some older one is not usable or shouldn't be used or anything. It's just that together we can create cool things. I think the second part of the question is not really about the cryptography, because like it asks about the security, computational efficiency, and scalability that drives the design choice. And I think so what I explained before, like in Ethereum, like we are aiming to be decentralized, to enable all of the people to run the node, to verify everything, to make sure that what you are doing is exactly what, basically like it's full trustless verifiability, right? I read the code of the client, I read the specs, I read the code, I run the code, and then I run my wallet that I connect to this node and I interact with Ethereum, and I don't need any third party. I can just do this all myself. It's full sovereignty, full trustless. And to be able to do this, we need to make the trade-off where we cannot just let like naively scale horizontally, in a sense that we're just gonna require the nodes to become more powerful, because then people, like mentioned here, won't be able to run it. And I believe that we are already like pretty high with these requirements, although still it's very much feasible to run it on a laptop. It's becoming harder and harder. And to avoid this, to make it like much more harder to avoid being like a centralized system, we need to make a trade-off where we find a design that is much more efficient, that is doing some clever hacks to enable more data throughput while keeping the requirements and the actual data that each node needs to process much lower. Yeah, I hope that answers the question. Open source software like Signal. Oh yeah, I was talking about Signal there in the intro. I'm sure I did. I don't remember it all, but it seems like I did. Else, yeah, auditing description and implementation about proprietary apps like WhatsApp require trust. My question is in the centralized platforms like Ethereum, how is the principle of everywhere? And this is the point, like what I said before, like everywhere. So I have the open source client code. The node that I'm running is open. It's completely transparent. And now if I'm using some contract on Ethereum, well, that's fair. Some contracts, some people might not care, but like the thing is, using a contract that's on Etherscan. For example, when you look at it at Etherscan, you can click on the code, you can go on Sourcify and see that it's been verified. So I have a mathematical proof. I have a clear proof that whatever I'm executing with my transaction is exactly the code that I'm reading. So it's not just open source, but it's fully verifiable that what I'm doing, this logic the transaction that I'm interacting, is really the case. So for example, I'll give you me as an example. I love Richard Stallman, as you could see in the intro. I love free software. I hate using proprietary technologies. For example, I don't use any banks. Today, if you want a bank, you need to install a proprietary app that spies on you. I'm not doing that. Instead of using proprietary app where I would have to trust somebody to do something with my money, I can go on Ethereum where everything is free and open, and I can exactly see what is happening with my money at every step. And of course, it's possible to create a smart contract and not publish it. We could still somehow analyze the bytecode to see what it's doing and figure out it's not malicious. But it's sort of against the principle, or like the good practice. I would say the biggest smart contracts, the actual applications you want to use are not going to be closed. They're always going to have verified code. So again, look into stuff like Sourcify. That's a great example. Yeah. Okay. ZK Stark scaling, zero knowledge rollups. Snarks are secure against quantum computers. Well, ECC used in snarks is widely believed to be susceptible to quantum computer attacks. We discussed this before. Question is that the reason both Starks and Stark globes are used for scaling because they both have strength. Yes, basically, yeah. There is certain evolution between this from Snarks to Starks, but still, there are still certain trade-offs. There are certain hacks how to make them more quantum resistant. And right now, the rollups are using there are rollups which I think. I'm not sure if somebody still is using Snarks, to be honest. Like I think ZK Sync was based on Snark. I'm not sure if the latest one is. And I'm honestly not so deep into all the rollup ecosystem, but I think with the Starks being prevalent because they are much more efficient, there are these trade-offs to consider. It's exactly what I was talking about before with the KZG, for example, where you look at this protocol or this cryptographic scheme and you need to choose, okay, do I want more effectiveness or do I want trusted setup? Do I want quantum resistance? And these protocols need to make their own decision. Ethereum is also making these, like with the lean being stratified. Yeah, I see somebody has a hand up as well. I'm not sure how many questions are left. We have like 5 minutes left, so I'll try to answer faster from now.
Yeah, we just have one question left from my
Okay,
slides. I don't,
that's awesome.
yeah, I don't know about the questions in the chat. So
Okay, let's
yeah,
do one.
let's move on.
Finish the slides, and then we can maybe do some additional
Yeah.
ones quickly. Lake rollups are presented as the primary. What are the potential security? Oh, okay. Okay. I've been reading the protocol intro and I'm curious about the analogy between the Ethereum network and the Ethereum in the crypto trading world. If the network is the centralized backbone, how does the fundamental actually directly influence and connect the public perceptions and the value of tree as a tradable asset? And to the full loop of technical decision to a market behavior. Okay, two things. So let me start with the rollups. And as I said before, the presentation that I was doing there is maybe sort of outdated. Like the rollup scaling roadmap is still there. It still happens, but it's maybe not the only priority we have right now. It's maybe not the only primarily scaling, but it still is important. Well, for example, now with Fusaka, we have the data availability assembly called PeerDAS. We're going to have much more cheaper data for rollups. However, what are the trade-offs? That's basically the question. Security trade-offs, yes. Because the idea is that the L2s, the rollups, they inherit the security of a layer one, technically speaking, right? But that comes with a bunch of asterisks because yes, you are verifying some data thanks to Ethereum, thanks to the layer one, but there is much more complexity built around it. So how do you enforce this verifiability? How do you actually do this? It's a lot more infrastructure, a lot more tooling that needs to be created around that introduces much more potential issues, much more potential attack surface. As we discussed before, it's all about the attack surface and more attack vectors that could be abused. So, for example, optimistic rollups are using the fraud-proof mechanisms, which is technically like 1 out of n and honesty, but in reality, these systems are often permissioned. It's hard to become one of the verifiers. And then who is going to post these? When you are posting the fraud proofs, you have very complex mechanism that detects the irregular state changes that would prove it would is. It's a lot of complexity, right? It's like the canon on optimism, for example. Then on the ZK, you have sort of a simple verifier on chain, which is nice and easy, but you have much more complexity on the prover side. Then another trade-off that's like a security trade-off that like, okay, you don't have actually the same level of security because there is some more stuff involved. But as it gets older, more audited, more lean, it's going best, and there is a centralization, the liveness issue as well. That all of these have centralized sequencers. So if it goes down, the liveness of the networks is limited. It's not a decentralized network, but it's another trade-off, not really security, but partially that people need to have some alternative way how to withdraw the money. And of course, best source on this is L2Beat. If you look into the L2Beat comparison, they have detailed deep dive into architecture of every rollup and what are their security issues. So look into that. And there was the analogy, the trading world. I don't really want to speak on this much because there is not much to talk about. Like the market just lives on its own. The market does whatever the TV says. I don't know. It's not really the protocol and the market are two very different things. From the protocol perspective, we want to make sure that the ETH as an asset is secure. It's the fundamental part of the protocol, right? It's being burned. We want to make it sustainable. We don't want to create some inflation spiral. So we have this burn mechanism that's creating a deflation, which is potentially has some impact on the market. But it's not our goal or our any sort of like thing that we care about what happens on the market. Like that's really up to the markets to decide. I would say it's more like from our perspective, like we want to make it as easy and possible for people to use, for people to build. I think from this perspective, what the best thing could be like, support the builders, people actually creating the businesses, creating the value, using Ethereum on top of Ethereum, and therefore like somehow drive the market. But that's really not the core protocol business. Yeah. Cool.
Yep, I think that's all from my side. We can go through some of the questions in the chats if there is any, and then we can wrap up.
Yeah.
I had a
Yeah, let's do
question.
like go ahead.
This goes to actually Chaudhry, not Mario. Chaudhry, Mario said some time back that in the process of asking questions that the client you choose to work with, because looks like most of us are new to working with the client, working with to choosing the clients.
I cannot hear you clearly. Is the question for me or it's for Mario?
It's for you, not for Mario.
It's okay. We can have it after the talk because
Yeah,
I
if you don't
think Mario
mind,
might have
I
another
already
need.
I will have to leave for another call soon.
Okay,
So
all right.
if we can do
Yeah,
a
yeah.
couple quick questions, please. Yeah.
I think we don't have any more questions, so I think we can wrap up. And after that, if the participants have any question for me, I can take that up.
Yeah, I'm part of your Discord, and you're also welcome to join the EPS Discord. By the way, one thing I wanted to say before we finish. So please use the EPF wiki and please contribute to it. Okay, so let me share you here is an invite for our EPS Discord. That's where we also coordinate on the wiki building and we discuss all these resources. So you can join also our Discord there. And as you are studying the EPF wiki, as you are using our resources, and you find them outdated, you find something missing, you find other cool resources, just please open a PR. I think that's also a great way how to start contributing to the protocol, how to learn using GitHub maybe. From whatever I spoke about today, I'm sure there is much of outdated stuff that you can update, so you can already start your contributions also like this. We sometimes have meetings for contributors, so check out the wiki and you can read and write, you can do both sides there as well. Hope you I will see you there as well. And thank you so much for listening. I see so many people answering now, so I'm glad that you enjoyed it. Again, I hope I wasn't too technical, but hope you got it all. So yeah, thank you so much, everyone.
Yeah, thank you so much, Mario, for your time. Yeah,
Awesome.
have a great day.
Have a great day, everyone. Thank you so much.